put all this. This one. Okay, thanks for having me, everyone. Today's presentation is going to be a little bit different. I'm approaching NLP from a completely different angle. It's from the angle of, I guess, innovation, application, going out, identifying an industry problem and figuring out whether NLP tools are good enough to fix it or not. By way of background, I'm a PhD student of linguistics at the ANU in Canberra. I use some NLP tools in my own research, which is in the Aramaic language. And I read historical grammars written by classical grammarians and use their frameworks to tag a corpus of Aramaic texts over 1,000 years and see whether those frameworks can expose patterns in syntactic change and evolution. And they do. This is a smart guy we're looking at. The sort of bottom line, or the kind of the underpinning theme, I think, that relates to this project that I'll be presenting is this idea of language change over time. And my supervisor's been great in sort of pushing me to get out there and communicate my research. And I've been doing that, but I quickly found that, to my surprise, not many people are interested in syntactic theory. And so I've had to kind of brainstorm other ways of translating or communicating parts of my research. And so to that end, I've been a part of a few innovation programs, which basically have got me thinking about a very specific, discrete part of my research that can be translated into something that could benefit people in Australian society. And the way that was done was basically going out and doing what's called like requirements gathering, speaking to a bunch of different stakeholders, understanding different problems. And one of the sort of problems that I gravitated towards was a problem in the Australian education sector. It's a whole can of worms, but suffice to say, some of the main themes that have come out of this sort of stakeholder consultation, I guess you could say, which is with school principals, parents, teachers, and students along the East Coast, was there's this sort of unanimous agreement that everyone hates NAPLAN. And that they would like, that the insights of for those unfamiliar with NAPLAN, it's a national standardized examination that school students take every 3 years. And it's one of the few reports that we have to understand how student writing develops over time. So one of the things that has come out of that is users would like something that's like NAPLAN, where it can reveal longitudinal trends in writing, but without having to do the exam, because that's stressful and teachers shouldn't be teaching for the test. And it's stressful for students, and it needs to have high level sort of trends that's easy for parents to understand, but backed up with some low level insights and sort of evidence-based sort of reporting for teachers. And obviously the investors are like, well, it needs to be simple and unique as well. So there's lots of sort of mouths to feed, I guess. And what I settled on was something which NAPLAN already produces, which is this report. But the idea is, the idea in theory is to create this report because it's simple and easy, and teachers and parents are already familiar with it, but make it automatic, make it instant, and somehow do it without an exam, and to make it to make it that much more difficult, try to back up some of those trends with actual evidence as well. So this was kind of the challenge, thinking how can we sort of develop a tool that would do this. The solution for this came a little bit sort of coincidentally, I guess. So I conducted this experiment, which I'd be lying if I said that I thought about this experiment sort of consciously. It actually happened organically. I was tutoring a student in Sydney. I've been tutoring students for about 10 years. And it just so happened that at the time I was putting together the corpus for my own PhD research. And it occurred to me, well, like, why not ask the student to provide, say, 10 of their essays, and I can plug that into the corpus tool that I was using and analyze that for trends over time. And it turned out, and like the student was, agreed to it, but it turns out he's got like way more documents that he was willing to share than I expected. And I thought, this is great. If there's anything better than assessing a performance based on 1,000 words at one point in time, it would be, say, 1 million words or hundreds and thousands of words, instead. So the documents that were provided cover 12 different subjects, from maths, legal studies, religion, health, and a range of sort of expositions, I guess you could say. So like worksheets, essays, science reports, maths extended response questions. My approach was, if it's writing produced from the student's brain, then it's worthy of linguistic analysis. So that's kind of the principle that I was taking with this. To sort of help automate the process, and I did this in tandem with some manual analysis using Lanxbox, which is a corpus linguistic tool. I used the open source packaged language tool, which is similar to Grammarly. It identifies errors in writing in English. And I basically processed this iteratively over each document. And the tool identified 13 different error categories and over 400 different subcategories. The output, which is extremely simple, two CSV files. The first one is just good old basic error frequencies across 4 writing areas, and then I've paired that with the date, because locating students writing at a point in time is needed for a longitudinal analysis. It took me a while to figure this out, but it was the last creation date metadata behind each Word document sort of provided that. I then sort of retrospectively went back and then produced a second table, because as a linguist, the numbers just weren't enough for me. I wanted to sort of see exactly what errors the model was picking up on. And so the second table produces or shows the errors in their context, or it's a quick analysis, keywords in context. I'll show you guys that in a second. So just to sort of, in broad brush stroke terms, there were over 10,000 errors identified. I re-annotated the 13 error categories across 4: spelling, grammar, syntax, and punctuation. You'll quickly notice that syntax is is poorly identified by the model, if at all. The closest categories I could sort of squeeze into the syntax category was compounding and collocations, which is not that adequate. And I think maybe just an important thing to note about the graph is that this isn't necessarily an indication or a reflection of the students' writing errors, or the proportion in writing errors in the students' work. Rather, I think it's a reflection of how well the model picks up on spelling errors, punctuation errors, etc. So that's something to keep in mind. The error frequencies were visualized in Power BI initially. You'll quickly notice, and I mean, I sort of ignore grammar and syntax just because there's not much, it's not very reliable from the model's point of view. But even in punctuation and spelling, there's lots of noise, or let's say, what do you call that? Anomalies, or sort of these spikes in the trends. And this is where the second table was good for me to do that additional deep dive and figure out what exactly was going on there. And the way that it was a very manual and laborious process. So all of the 400 or so errors were visualized, and then I literally I went through them one by one, and then looked at the specific errors. There was a lot of junk, but there was actually some good stuff too. So there's sort of some interesting trends. You just have to mine for them. Well, at least I did. I'm sure there's, well, let me pull up the example, which is the case of possessive apostrophes. And this is just to show the point that, in addition to the numbers, I can do this deep dive and see exactly what's going on. So I'm not sure if you guys can see this. So let me come here. Sorry, just one moment. Here we go. All righty. So there's 30, I think they showed there were about 30 or so errors between April and August. And I would come into this platform, this part of the data, look at each of the errors in their sentential context, look back at the documents that they were found in, and sort of do additional deep dives there. There were three main reasons why there were these sort of broad deviations in the results, and this is going to motivate sort of additional cleaning up of the current workflow. But one is that a lot of the documents that the student has are downloaded from the web. They're not even their own. So we're going to have to look at extracting docs based on authorship from the document metadata. A big one was version control. So the student would write an essay, the teacher would provide comments, they'd create a second version and add, make some changes. And so you'd get double counting in errors, and that contributed to a lot of the spikes. And the last one was a lot of errors were picked up on in English essays where they quoted things from texts like Shakespearean texts. And so those obviously need to be stripped out as well in sort of future iterations of the project. Some of the interesting things that have come up out of doing this sort of deep dive analysis, and this is sort of speaking to one of the points that I think Ed made yesterday with regards to the benefits of investigating errors, or sort of the deviations or whatever more thoroughly. So in the case of the possessive apostrophe, I initially thought it was strange that, as in example 7, the student uses possessive apostrophes in some cases, but then in 1 and 2, he doesn't. And you're like, all right, well, he's just lazy, not a big deal. You're not going to mark him down for that. But then you look at example 6 and 7, and you're like, well, hold on a second. He's employing the plural form of the genitive noun, which tells me that examples 1 and 2 are probably not cases of him forgetting the apostrophe. It's cases of him inflecting the noun for the plural. And so you can schematize the student's grammar for genitives, or in this case, like the king's house, or with the possessive apostrophe. In the student's grammar, it's plural noun plus noun, as opposed to the standard genitive S. And this is like a sort of a quirk in the student's mental grammar, hypothetically, because it's really hard to sort of do empirical tests on syntactic theory. But the idea here is, that the student has a unique sort of grammar, and this is something that's called syntactic reanalysis in the literature. I won't bore you with that, but it's been used by linguists, historical linguists, to both identify authors in manuscripts and also understand motivations for language change. Some of the sort of future work, I'll spend a moment on this. Probably the most interesting one is generative modeling. The idea here is for to use the text per year to generate just like 2 or 3 sentences. So teachers can, if teachers want to say, okay, give me an impression of how John wrote in 2018, they can sort of read 2, 3 sentences, compare that with 2019, 2020, potentially fine-tuning the output to make sure that errors that are statistically significant are represented in that. And sort of I think the more higher level opportunities here, and with the first one, there's been some interested, well, investors have expressed interest in this idea of an automatic notification tool for teachers that's statistically driven. So letting teachers know when students have shared errors or when performance declines based on increasing error counts, and also using student demographic information to look into things like error conditioning. One of the opportunities, though, that I'm more sort of excited about is creating some sort of bartering service with students where they can go online, upload their schoolwork for free in exchange for these insights, and then we can preserve their work. Because unfortunately, a lot of the students I've spoken to, they just delete it after year 12. And I was sort of horrified to learn that. And I think from a linguistic point of view, it's a gold mine. And I think it's worth saving that. So I'm kind of going to look into how that might work more, hopefully into the future. So that's about it. That's about it from me. Happy to answer any questions, and yeah, thanks for your time.
Thanks, Charbel. Do we have any questions?
I was interested that you were making a distinction between syntax and grammar, and what you meant with syntax, you were talking about case and apostrophes and things, seem to be a bit more like morphography and orthography.
Yes.
And yeah. And then the second part was you focused on the errors, the negatives. Wonder if you've looked at the positives, so more sophisticated language, longer sentence, apposition rather than and coordination, things like that.
Yeah, great points. Thanks for that. So one of the things that I'm hoping to, let me see if I've got them here. Yeah, other sort of models that I was interested in using on the same data are things like, I've seen things on like the readability of sentences, vocab and syntactic complexity scores. So I think that's, I mean, I think it's there, it's available, it's just a matter of doing. So that's certainly one. As far as, yeah, I have not looked at any positive trends. So that in the sense of where the error frequency decreases, therefore performance is improving. So I only looked at, I basically filtered the stats for positive gradients. So in terms of the error count. So there's also scope certainly there for looking at improvements as well as performance decline. And to your last, to the last point with regards to how you classify, you know, grammar and syntax, it is a gray area, and I think it's you know, depending on your sort of theoretical persuasion, you'll kind of do it differently. So something like the possessive apostrophe one that we saw is a good example of like, well, it's a possessive apostrophe, it's punctuation, but it serves the function of marking a grammatical relationship. So therefore, is it punctuation or grammar? So I guess that's what I meant by gray areas. I'm not sure. Yeah, I'm not sure. I guess it'd be interesting to sort of retag them under both and just seeing if it makes a difference with the results potentially. Yeah. So hopefully that's sort of.
Any other question? I have a question, it's more curiosity than anything else. So you show us that you use a Python library and the error typology is very big, right? So
Yeah.
that tool recognizing many errors that then you abstract into 4 categories. In those, in that big typology, do you have any errors relating to fluency?
No. And in terms of the sort of, let's say, error taxonomy, one of the things that needs to be done, I think, is, so at the moment there are 2, yeah, I won't show it now, I guess, sort of, At the moment, there are two levels. There's the error subcategory, there's 13, and then there's 400 ones within that. I think there needs to be a second and third in between. So for example, for the higher level category of style, the model will detect an error under the category of gonna instead of going to, lemme instead of let me, and the name of those errors are just gonna and lemme, when you could group those together into a sort of something like informal or whatever. So yeah, I think that there's definitely scope to do some further reannotation. Yeah, but nothing on fluency. Sorry to answer your question. Yeah.
Thanks.
Thank
Thanks, everyone.